Good afternoon, everyone. So, this is the seventh week of the online session. So, today's classes we are solving some problem and also talk about some properties of the polymer material. So, before starts today's classes, I am Pobir Maiti, teaching assistant of this course, and course instructor was Professor Obhijit P. Deshpande. Course name Polymers Concept, Properties, Uses, and Sustainability. So, as of like polymer, which have the different property rather than this another material. Like if you show a metal which are showing the elastic behavior, but as a polymers, it have shown both viscous and elastic property. So, so as of now, the polymers are called a viscoelastic material where we can show both the viscous property and elastic property. So viscoelasticity, what is the viscoelasticity? Viscoelasticity is the property exhibited by the polymers and it refers to their combined behavior of viscosity, that is the resistance to flow, and elasticity, that is the ability to come back its original shape. The property is a result of molecular structure and the interaction between the polymer chain. So when you tell about the polymer, so there will be two properties then, like the viscous property and elastic property. So if you are more deep on the viscous property, like about the liquids when it flow, so it the wall have the resistance to flow the liquid. So like a polymer where the long chain, so when it will be melt, so that also can similar behavior type of viscosity. So viscosity, polymers like liquids exhibit viscous behavior, meaning they can flow and deform under the influence of applied force. The resistance to flow is related to the polymer's molecular weight and temperature at which it is processed. Higher molecular weight polymers typically have the greater viscosity. Also, you know that relation between the viscosity and the polymer molecular weight. So if you go to the relations, you find out that there will be some relation between the viscosity and molecular weight, and with increasing the molecular weight, polymers have the higher viscosity. Elasticity, polymers like solid have the elastic behavior, which means they can deform from the subject to a force but return to the original shape. When you stretch a rubber, so what will happen? You stretch the rubber and it will be come back its original position when you remove that force from that rubber. So that property of coming back to its original shape or original position, that called elastic property. So like rubber, if you stretch this rubber like long time or you stretch the rubber beyond its limit, then it will be break. So then it will be not come back its original shape. So that time it will be plastic behavior, that is the rubbers going to changes its shape and it will be takes time to come back, but the elastic behavior will be like this. It automatically come back to our original positions after removing the stress. The elastic response of the polymer is due to the entanglement of the polymer chains and forces that hold them together. So like a polymer, so there will be chain entanglement. So when we stretch the polymer, so that chain entanglement will be now straightened enough. But when you release, due to the due to that lower amount of due to that reduce the amount of entropy, that polymers come back to its original shape, and and polymer like a long chain, so that type of material like chain entanglement and chain straighten, so that are showing that elasticity behavior. So these forces are typically weaker than those crystalline solids, which is polymers can deform more easily. So if you as compared to the crystalline solids, if you and the polymers, so polymers cannot sustain that much amount of load as compared to the solid. So solid like metals can absorb much amount of load and it's showing elastic behavior, but polymers with a small with a limiting amount of load it's showing elastic behavior, but above that it's not showing, it may be deformed. So what the viscoelastic behavior like? So this may be the time dependent deformation. What sets a polymer apart it is their time dependent response to stresses. So time dependent means when you apply stress into the polymers and polymer that increase its length or increase its shape, and when you release the stress it cannot come back its original positions. If it is come back its original position immediately, that we can call it ideal elastic material, that is a plastic elastic material. But when it will take times like a viscous type behaviors, so then we called as the viscous material. Instead, it exhibits a combination of the both behaviors showing time dependent deformation response. Like it will also come back its original shape, but it takes times to come back its original shape. Creep and stress relaxation. What is this? Creep is a gradual deformation of the polymer over time when subjected to a constant load or stress. Like when you rubber and you constantly some weight you give into this rubber. So what will happen after some time? You are showing that sometimes it will be not changes its shape, but when you are long time at a constant load, maybe this rubber can gradually changes its shapes and it will be more deformed. That is the strain will be more increase. So this is the behavior of viscoelastic behavior. So with applied to certain load, a constant load, the stress is certain amount of load stress can also increase the strain of this polymer material. So creep, so this also come in the exam. What is the creep? So creep behavior should be like that, where you applied a certain amount of constant load and you find out that deformation in the polymer shape. Stress relaxations is the decrease in the stress over time while the polymer maintain constant strain or the deformation. So stress relaxation is like that. To like a polymer, I have told that with the certain time we need lower amount of applied stress to deform this polymer. So with increasing time, if you decrease the stress and maintain same constant strain, so that we will call stress relaxation. So both the phenomena are mainly characteristic of the viscous type of material, because this time dependent behavior will be happen only that viscous type of material, viscoelastic type of material, not like a elastic material. So polymer can only show this type of behavior. That also frequency dependent. The viscoelastic behavior of the polymer can also be frequency dependent. So frequency dependent. So at higher frequency, polymers tend to behave more elastically, while at the lower frequency they exhibit. You able to see my screen? So as I am telling about the viscoelastic behavior of the material, so viscoelastic type of behavior is the combination of both the viscous and elastic behavior of the polymer. So like a polymer which have the more chain entanglement and more the size due to this, so this material can show both the elastic and viscous behavior. Elastic behavior means that will be come back its original shape with immediate if you taken out the load immediately it will come back to its original shape, but viscous behavior will be like that. It will be time dependent. It will take time to come back to its shape. So like polymers are have the both the behavior, viscoelastic behavior. So polymers also polymer property can be dependent on the frequency. So at higher frequency, the polymers tend to behave more elastically, while the lower frequency it will be exhibit more viscous behavior. This frequency dependence essentially is understanding the behavior of the polymers in the dynamic application. So when you are applied this polymer in a dynamic application, that is where the certain amount of load is dynamically added into the polymer system. So that time we must to know about that frequency dependent of this polymer. So such response is the vibrations and oscillatory force. Also like the viscoelastic behavior. So viscoelastic behavior also temperature dependent. That is the viscoelastic properties of the polymers are highly temperature dependent. Polymers become more viscous at lower temperature. That is the more elastic at higher temperature. The transition from glassy state to more rigid. Glassy states, you know about the polymers. Glassy states is the below the Tg, that where the polymers are become brittle, and above the Tg the polymer become flexible. So below Tg the polymer like a rigid and glass type, and above Tg the polymer is a rubbery state. So before Tg the polymer mainly the viscous behavior, and above Tg that is the rubbery states, that is the more flexible and rubbery like type behavior. So it's an example of temperature dependent behavior into this viscoelastic polymer material. So application of this viscoelastic behavior, the viscoelastic properties of the polymers make them suitable wide range of applications such as automotive industries like tires and shock absorber. Like a tires where the load is dynamically added by the car into the tires, and the tires are mainly made of this polymer material. And this polymer material, so if we want to make the tire in a metal type of material, solid material, so that cannot absorb the load and shock of this car. So maybe that accident may be more happen when you are doing that like more solid or more elastic type of material. But when you are using that viscoelastic material as the shock absorber or in the tires application, so that can absorb the shock of the your car and can also take the load of your car. So for this, that materials must have these viscoelastic properties. So in construction, polymer modified concrete, biomedical vehicles, biomaterial tissue engineering also are application of this viscoelastic behavior of this polymer. So understanding where you can understand this viscoelastic behavior. So viscoelastic behavior properties essential is designing material and products with the specific mechanical and thermal rheological properties. So and you can get this viscoelastic property, and you can understand this property by this rheology or dynamic mechanical analyzer testing or creep testing, like that. So now I solved some problem. So this problem are earlier also we have related some this problem. So if someone found out that degree of polymerization of the polymers which have the molecular mass of 1 lakh gram per mole, and the polymer is polyacrylonitrile, so how can we calculate this polymer degree of polymerization? Hello. Hello. You able to hear my voice?
Yeah, yes, sir.
Okay. So you have to find out the degree of polymerization of this polymer. So how we can calculate the degree of polymerization? So first we have to know about the polyacrylonitrile. So what are the repeating unit of polyacrylonitrile? Did you know that repeating unit of this polyacrylonitrile? So like any acrylic group will be like this, there will be some double bond, and this double bond there will be some group like polyvinyl chloride, polyacrylic acid. So instead of polyacrylonitrile, that is cyanide group are present. If you tell about that polyacrylic acid, so there will be COO is present. Polymethyl methacrylate, some methyl and methyl acrylate groups are present into like this. So now we have to find out. So this will be our monomer. So from here, the polymer will be like this. So this will be our CN, and this is our repeating unit of the polymer. So now we have to find out that mass of this repeating unit, because we know that degree of polymerization is equal to over molecular weight of the polymer. So molecular weight of the polymer divided by molecular weight of the repeating unit. So repeating unit, so this will be CH. So if we calculate, so there will be CH, that is the 13. There will be 14. Then this will be CN, that is the 2 carbon, that is 28. Carbon, that is 24. Then there will be one hydrogen here, that is 1, and nitrogen will be 14, that is the total 15. So how much it is coming? 15 plus 14 plus 24. So this is the repeating unit like acrylonitrile. So now we have to do this. So it will become around 53. So now what will happen? So we get the polymer repeating unit molecular weight. So now we divided this 100,000 divided by 53. So this will be our degree of polymerization. So like similar type of like there, if you know the degree of polymerization, you can calculate the molecular weight. Or if you know that repeating unit and molecular weight, so you can calculate the degree of polymerization. So all of these cases we have to know about this, the repeating unit, what repeating unit are present into our polymer system. So it will be comes around 1886. So now in another question we have to find out, name the polyamides made from the following monomers, draw their structures formula of one repeating unit. So first one is the caprolactam. So from caprolactam what we get? Polymer. So caprolactam is a 6-member ring without CONH bond. So if you do this caprolactam, so this will be giving this nylon 6. So this will be when the monomer like, so this will be like this, NHCO. So this will be like this. There will be 5 CH2. There will be 1 like this. So in this, what will happen? Some initiator will be come here. So the ring will be open and we are getting the linol 6. Similarly, omega undecanoic acid. So from this undecanoic acid, so there will be presence of 10 CH2 group. Undecanoic acid, that is the total number of carbon in the undecanoic acid will be 11. So into that 11 there will be one carbonyl group. So which will become at the repeating unit structure, and so there will be total number of 10 CH2 group present in that polymer. So that we are called nylon 11. Similarly, dodecyl lactam. So it is the 12th member. So from dodecyl, that is the 12. So there must be present 12 carbon units. So from 12 carbon unit, one is the C double bond CO, CONH, and that repeating unit will be CH211. Similarly, that when there will be multiple functionality presence into the polymer like hexamethylene, diamine, and sebacic acids. So these three polymers are first caprolactam, omega decanoic acids, and dodecyl lactam. These all are coming from that ring opening polymerization. So you break the ring and you get the polymer. And from here, these are come the condensation polymerizations where the two functional group are needed. One is amine and one is the acid, and we are making the amide bond. So like hexamethylene diamine and sebacic acid, so hexamethylene diamine have the 6 CH2 group. So for this reason we are called, this is the nylon 6. And sebacic acid, you know that there will be 10 carbon unit present in the sebacic acid. So that is the two COOH, this one and this one, and middle there will be 8. So total is 10 carbon unit present in the sebacic acid. So this are example of the nylon 16. Similarly, hexamethylene diamine and decandioic acid, so that is the 12 unit of this 12 units of carbon. So this will be the hexamethylene diamine. So this will be 6, and that from that acid this will be CH2 whole CH210, and two sides are COOH. So these are the nylon 16. So so from here, so if someone give an example of the some ring opening polymerization, so you can tell that ring opening polymerization for the caprolactam can do the ring opening polymerization, but the condensation polymerization will happen when there will be two functional group are present. And also we can identify this which is nylon 6 and how this name are called. What is the nylon 6? So first the amine will become in name, then the acid unit will come. So then we have to find out some what is the functionality of the monomer shown here. So like in this monomer, so you have to find out the functionality. So if you want the first cases in a free radical or ionic condition reaction around the C double bond C bond double bond. So what the functionality of this? So there will be two C double bond C, here also C double bond C. So if you have the two functional group also here and also here two functional group. So if the functionality is the in the polymers, what number of functional group are present? So when you tell about that in the double bond, so double bond there will be two double bond. That is the total number of functionality is 4 because there will be two sides it possible the polymerization can happen. So that is the total functionality is 4. Then in a reaction between produce the amide linkage. So if you produce the amide linkage, so producing amide linkage, so another like this type of monomer will also come. So when another monomer comes, so from the acid and amide, so they can produce amide linkage, and also this C double OH and one amine from another amino another monomer, so that also can produce that amide linkage. So the probability of the two amide linkage is from the two sides. So this side, this side. So the produce of amide linkage and the functionality of this will be 2. Then in the reaction of the produce ester linkage, so ester linkage only possible when this acid will be react with that another alcohol. But here the only one acid is present in our monomer. So for these cases, the producing the ester linkage, the functionality will be 1. Now we have to find out, so you know about the plasticizer. So plasticizer is a type of materials what we add into the polymer system and polymer system. If we add the plasticizer, the polymer, the free volume is increases, and if the free volume is increases, the TG will be low. So TG will be low means the polymers are more application, that is the polymers. So like when we are when the TG will be low, it's important when you are apply this material like in India, our temperature is around 25 degrees centigrade. But when you go into the Russia or Europe type of country at the winter time, the temperature will be minus 5 degrees centigrade. So if is your polymers which TG value is 10 degrees centigrade, so if your polymers show the TG value is 10 degrees centigrade, that means the below 10 degrees centigrade the polymer become brittle. So in India this polymer behave as rubbery material because the temperature is 25 degrees centigrade. So in India, so it will be behave like a rubbery material, but in Russia and like Europe countries, it will be behave by the temperature minus 5 degrees centigrade, so it will be behave like a brittle material. So rubbery type of materials, so that can use the tire application or any application, but brittle material we cannot use this. So to make this TG more lower of this, so you have to make a polymer side layer which TG is minus 20 degrees centigrade. So if the TG is minus 20 degrees centigrade, so it will be applicable in the both this country like in India also or in Europe country also. So to reduce the TG of the polymer, so we add the plasticizer into the polymer. So 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 we, so so there the question was the how much of low molecular weight plasticizer TG minus 100 degrees centigrade should be added a film of nylon 6s in order to TG reduce 80 degrees centigrade to 40 degrees centigrade. So you have to reduce the TG from 80 to 40 degrees centigrade, and TG of that plasticizer have the minus 100 degrees centigrade. So you know that TG of the blend, that is the TG of the blend equal to W1 by Tg1, that is the TG of polymer, plus W2 by Tg of plasticizer. So this is the polymer I have drawn as the PO, and this is the plasticizer. So now you know that Tg of the blend should be how much? 40 degrees centigrade. So now you have to convert this 40 degrees centigrade to how much in Kelvin. So 40 degrees centigrade will be 273 plus 40, and the Tg of plasticizer are already given. So Tg of plasticizer will be 273 minus 100. So that will be 173, and Tg we need 80 degree centigrade. So that will be Tg of the blend will be 273 plus 80. So if you put 1 divided by 273 plus 80, W1, so we have to add the plasticizer. So you don't know about the how much amount of plasticizer. That is the W2 we have to find out. So W1 equal to will be 1 minus W2. So 1 minus W2, the Tg of the polymer is 273 plus 40, and W2 is that W2 by this. So from here you can calculate the Tg of the polymer blend. So we have to find out the W2 value. So if you find out the W2 value, so you can tell that how much plasticizer we need to, how much fraction of plasticizer we need to add into the polymer, so that can reduce the polymer Tg from 80 degrees centigrade to 40 degrees centigrade. The next one that I have given some example of this stress strain behavior. So these are important, that the stress for the brittle plastic, the stress will be stress when we need to more much amount of stress we need to apply to to increase the shape of this plastic. This is the example of tough and strong plastic. This is the example of hard and tough plastic, and this is the example of elastomer. Elastomer also is rubber. So if you repeat once again, so like a viscoelastic material, you know about the viscoelastic property. So viscoelastic property like this, where the polymers, due to that higher molecular of the polymers, so polymers have the chain entanglement, and due to this chain entanglement, and the polymers showing both the behavior viscous and elastic behavior. So viscous behavior will be like this. There is the polymer can show that liquid type of behavior, that is the resistance to flow, and elastic behavior, that is the it will be come back its original shape after after changes itself by the stress. So polymer have the both the behavior, viscoelastic behavior. So like viscosity, what is the viscosity and what is the elasticity? So viscosity is the polymers like liquids exhibit viscous behavior, meaning that can flow, deform and influence on the applied force. The resistance to flow related to the polymer's molecular weight and temperature on which is possessed. Also you know that relation between that viscosity and molecular weight by the Mark ionic equation, that is the specific viscosity and the polymer molecular weight relation. Like elasticity, elastic polymer also behave like a elastic material, but not as compared to that our metal type of system. Polymer can hold that load lower, and if you apply more load into the polymer system, so that can deform its shapes. Time dependent deformations. So what is the time dependent? So what sets a polymer? So time dependent response to stress. When the stress or force is applied into the polymers, it does not immediately respond like a ideal elastic material. That is the its come back its original positions, but it will take time to come back its original position. That is known about the time dependent deformation. Creep, what is the creep and what is the stress relaxation? Creep is the in a polymer material you applied a constant stress, and due to the constant stress, what is the deformation in the polymers, that is known about the creep. And stress relaxations, that is the stress relaxation is the decrease in the stress with maintain the constant strain, because with time we need lower amount of stress to maintain the same strain. So both phenomena are applicable for the viscoelastic material like polymer. So viscoelastic material have that also behavior like frequency dependence. That is the when we are the applied dynamic load or dynamic application of any material. So this the polymer should showing the frequency dependence behavior. And temperature dependence behavior, that is the viscoelastic properties of the polymers are highly temperature dependent. That it that is the with the lower temperature, that is a polymer like glassy type behavior, that is the elastic, and higher temperature more flexible, that is the rubbery temperature dependent behavior. So what the application of this? So this can application in the automotive tire industry, like the tire shock absorber, etc. So how we can know about the viscoelastic behavior? So we can do that rheology, dynamic mechanical analysis, creep testing to characterize this behavior of the polymer. So then we have solved some problems. So we found out the degree of polymerization of polymer. So you have to know about the what the repeating union molecular weight. So if you know the repeating union molecular weight, we can calculate the degree of polymerization. Similarly, if you find out that what the repeating unit present and what is the name of the polymers, so like caprolactam, gamma and decanoic acids, so these are nylon 6, and when there will be two functional groups, so we are taking the two functional group as consideration. We call that nylon 610, nylon 612, like what amine and what acid are comes to give a polymer. Then we are told about the functionality. So functionality for the polymers, uh, what number of functionality there, what is the probable position polymer can grow. So like this double bond, there will be total 4 position the polymer can grow. So there is the 4 functionality for this amide to making the amide. So there will be 2 position where the amide can be from, there is 2 functionality, and the ester may be from only from this side. So there the functionality of this then the ester linkage will be 1. Then we told about a mm, equation where the polymer blend, how much plasticity we need to add into a polymer system to reduce the temperature. So this is the similar equation of the Tg of the blend equal to that weight fraction of the Tg of the polymer and weight fraction of the Tg of the another blend, which is the complete, so that should be completely miscible in the polymer system, like a plasticizer that can miscible into the polymer system or any polymer blend. So from here we can calculate that how much weight fraction of second polymer, or how much weight fraction of the second plasticity we need to add into the polymer system to reduce the temperature. Then I will talk about that stress strain behavior of the some polymer, like when it will be brittle plastic we need more stress, when there will be tough and soft plastic, that is this point it will be like elastic type of behavior, but from here it will be some plastic behavior. A hard tough plastic, tough means that toughness is come to the total load bearing, total uh, the toughness is coming due to that when the area of the stress strain curve will be high, the toughness will be high. So the for this hard and tough plastic the area should be high, so for this reason there will be more plastic deformation. The elastomers, so elastomer has the strain, with increased strain the stress, lower amount of stress needed to increase the strength, so these are the rubbery type of behavior. So thank you. In next class onwards, we are going to solve some another sets of problem. Thank you. We can meet next week. Bye.